Welcome to our first online study session. This is MAT1033C and this is the review for test 1. I hope everybody can hear me. I'm going to walk you through a couple of features that you guys can use meanwhile we are hosting this study session to communicate with us. So I can see who is logged on. So hi everybody, and if you have a question, you can either type into the text box or raise your hand, and then my coworker will chat with you, answer your questions, and let me know if it's something that we can share with the rest of the group. Just to make sure that you guys can hear me, please find that hand button. It looks like this up here, and press it so we know that you guys are attentive. Okay, I already see a couple of hands. Very nice. So once everybody raised their hand, then we can start with the questions. The question's going to be similar to your test, and make sure to stop us if something is unclear and to kind of participate so we know if we're doing a good job here. So very nice. I'm gonna put all your hands down now, and let's move on to the first question. So this is question number 1 on our study guide, and it says solve the inequality and give the solution set in both in set builder notation and in graph form. So when you have an inequality with an AND statement, you basically solve the two inequalities separately. So you need to isolate the variable, which means we're going to solve for x on both sides. So let's start over here. X minus 2 is less than 1, and let's move the 2 over by adding it to both sides of the inequality. So we get x is less than 3. Now let's do the same thing on the other side. Isolate the variable, so let's subtract 3 from both sides, and we have x is greater than or equal to -1. Okay, so I already put a little graph here. Let's graph this now on the on this little graph. Let's start with x is less than 3. So I actually need to continue my graph a little bit. I just noticed I don't have a -1 on here. So right here would be 0, and then here is -1. My bad. Okay, so now we're ready. So we need x is less than 3. Right here is 3, and less than, the numbers that are less than 3 would be to the left of 3. And because we have this type of inequality sign, which goes with parentheses, so our parentheses should go like that. And then we have x is greater than or equal to -1. So right here is -1. And because we have this kind of symbol, the greater than or equal to symbol, we're going to use brackets. So right here, x is greater than, the numbers that are greater than -1 would be to the right. So our bracket will go in this direction. And the numbers that are greater would be to the right of here. And the numbers that are less than 3 would be all in the middle. And because it's the AND statement, which means only what is shaded by both of the inequalities would be a solution to this inequality. So only the part that is in the middle would be a solution. So writing this now in set builder notation, we start with our curly braces, and then x, this line means such as, and then reading from our graph, so the shading starts at -1, and because we have a bracket, we need an less than or equal to sign, x in the middle, and then x is less than 3 because we have parentheses and closed curly braces. Okay, let me complete this chart up here. So the less than or greater than symbol goes with parentheses, and the greater than or equal to and the less than or equal to goes with the brackets. The and would be the shading that applies to both of the equations, because remember this would continue here for one and continue here for the other, but only what is shaded by both applies to and. And then you can also get the version of or on your test, and or would include everything that is shaded. Let me see if there are any questions from our audience. Okay, no questions, and let's move on to number 2. Number 2 is solve the compound inequality and give the solution in interval notation. So we basically have two inequality signs. What we have to do is we need to solve for x, and x gonna stay in the middle. So if I look at this problem, what I would like to do first is I would like to get rid of this division bar. So to eliminate this 4 in the bottom, I'm going to multiply by 4. Because if I multiply by 4, this 4 on top and in the bottom would cancel out to be 1. So that's my goal. I'm trying to eliminate it. But what I do to one part of the compound inequality, I'm going to have to do to all the other parts as well. And a compound inequality has 3 parts. Okay, so as I said, in the middle it will cancel out and we are left with 4 minus 8x. And then on the left side we have to multiply 4 times negative 5, which is negative 20. And on the right side, 9 times 4 is 36, so less than or equal to 36. Okay, continuing to get x by itself, my next step would be subtracting by 4 on each side. So negative 20 minus 4 is negative 24. And I'm left in the middle with negative 8x less than or equal to, and 36 minus 4 is 32. Okay, now dividing by negative 8 to get x by itself on each side. So in the middle now x is by itself, and I want to ask the audience, because with inequalities there is like this little additional rule. So what happens if I multiply or divide by a negative number? I cannot forget that, and you're probably going to be tested on that. So your question on the test most likely is going to have this kind of rule in there. So can you guys type into the text box what happens, or what do I have to do when I divide or multiply by a negative number? Gonna give you guys a couple of seconds. I can do my division already meanwhile you guys are thinking and typing. Negative 24 divided by a negative 8 would be a positive 3, and 32 divided by a negative 8 would be a negative 4. Okay? So I'm kind of giving you guys a hint because this is the only thing I didn't do yet. So we have some answers. Johnny, what is it? All right, you guys are very good. So if I multiply or divide by a negative number, and most of you answered correctly, I have to also change the inequality signs into the opposite direction. I had a less than symbol, so I need to change it to greater than, and this one was less than or equal to, so that becomes greater than or equal to. Good job. So before I write it in interval notation, I like to graph it on a number line so I get a better idea, and it also helps me to write it in interval notation because I just have to read it of my graph. So I need to make sure I have a -4 on my graph. Somewhere here is 0. And then also I need a 3. So I always read my inequality from the x. That makes more sense to me, but however you deal with graphing inequalities is fine as long as you're getting the right answer. So I'm saying x is less than 3, which means the numbers to the left. So I get a parenthesis. Remember, I don't have that equal bar under the inequality sign, and less than would be shaded to the left side. And then again, x is greater than or equal to -4, so now I need a bracket because I have that equal bar on the inequality symbol, and the numbers that are greater than -4 would be to the right. So everything in the middle would be shaded. Now I'm ready to write my solution in interval notation, just reading it off the graph. I have a bracket, it starts at -4, and my shading ends at 3, which has parentheses. So this is my solution in interval notation. All right, I don't see any questions, so let's go to number 3. Number 3 says solve the absolute value equation. So when we have an absolute value equation, we basically gonna have two different equations, because absolute value is the distance or the units on the number line in either direction. We're gonna have two different statements. So the first one, you can let me just copy it down, and before we can write our two statements, actually we need to isolate the absolute value bar, which is right here. So to get the absolute value by itself, we first subtract 1 from both sides, and we are left with -2z minus 5, and that is equal to -5. And then we divide by -2 because this indicates multiplication, and the opposite would be division. So divide by -2 on both sides, and you are left with z minus 5. And -5 divided by -2, I'm going to leave it as a fraction, but I can simplify the sign. A negative over negative is a positive, so 5/2. So now I'm ready to write my two equations. You always need to isolate the absolute value first before you can write your negative and your positive version. So dropping the absolute value bars, I get z minus 5 equals 5/2. And then the second version would be z minus 5 equal to -5/2. Again, we need to solve both of these equations for z. So let's add 5 to both sides. And then z is equal to 5/2 plus 5. I could do that in my calculator, but I don't know how many of you guys know how to convert it back to back into a fraction using the graphing calculator. You can type it in if you guys want me to show you on the graphing calculator how to convert a number back to a fraction. If not, I'm just going to do it by hand. When I add or subtract fractions, I need the same common denominator, so I'm putting this one over 1, and then my least common denominator would be 2. So this side is already 2, and the other side I have to multiply the denominator and the numerator by 2. So 5/2 plus, I'm getting 10/2. And now I can actually add the numerators. So z would equal 15/2. I have to check if I can simplify this fraction or reduce this fraction into lowest terms, but 15/2, they don't share a common factor, so that's fine. And I believe in the test, most of the answers you actually have to type in. So if it doesn't specifically state to convert it into a decimal, don't do it. Just type it into a fraction, and it can be an improper fraction. So this is my first answer. And then my second equation is right here. So again, I have to add 5 to both sides. And I am getting -5/2 plus 5. Again, I have to find the least common denominator, which is 2. So multiply bottom and top by 2. So z equals -5/2 plus 10/2. Now add the numerators, and -5 plus 10 is 5/2. And this would be my my second answer. Usually you write your solutions to an absolute value equation like that, and in your test make sure you write the smallest fraction or smallest integer first. In this case, the smaller of the two fractions would be 5/2, and then 15/2. All right, I guess all of you know how to use the calculator to convert between fractions and decimals. I didn't see any questions on that, so I guess we can just move on to the next problem. Okay, this one is number 4, and it says graph the linear equation by finding and plotting its intercepts. If you are given a linear equation and you are asked for the intercepts, you basically plug in zeros, because the intercepts, the x-intercept would be, if this is the point on the coordinate system, this is your x value, this is your y value. For the x-intercept, you know that your y would be 0 and vice versa. So if this is your x and this is your y, for the y-intercept, your x would be 0. So you're basically plugging in zeros into the equation to find the corresponding value. So let's find the x-intercept first by plugging in a 0 for y and then solving for x. So I can just take out the 0 and then dividing both sides by -4. So x equals a +3 right here. And then finding my y-intercept, now I have to plug in a 0 for x. And -4 times 0 is just 0. So I'm left with -y equals -12. To eliminate that negative in front of the y, I can either divide or multiply by a -1. I'm choosing to divide by a -1. So now y is equal to a +12. So right here, my y-intercept is at 0, 12. Now plotting those points on my coordinate system, and I'm seeing I did not make my y-axis long enough, but in your test, for this particular question, you will have multiple choice. So one of the 4 choices will have the correct graph. So I'm going to add 2 lines here to make it all the way up to 12. Okay, now I'm ready to graph my 2 intercepts. My x-intercept is at 3, 0. So 3 units on the x-axis, 0 on the y, right here. It's my x-intercept. And then my y-intercept would be at 0 in the x direction and 12 units into the y direction, so right up here. And then we're having serious issues graphing straight lines here. So whatever it's going to come out, it's supposed to be a straight line going through these 2 points. So I think I did pretty good without a straight edge. But like I said, and I hope some of you were able to print out the guide that I uploaded last night to the online study session. And in that guide, you would see 4 different answer choices, and the correct one would be choice A. All right, I'm going to give you a few seconds to digest this material. I know graphing is one of the most difficult topics. And then we're moving on to number 5. Find the slope and y-intercept of the line. Okay, so we are given an equation and we need to find the slope and y-intercept. There is a form of the equation which is called slope-intercept form, and that would be y equals mx plus b. Many of you have heard that form of equation plenty of time. So to be able to identify the slope and identify the y-intercept, we have to solve the equation for y. So let's do this over here. Let's isolate the y variable. So first, let's move over the 9 by subtracting. And I'm going to write the x first and then my 9. And that would be equal to 8y. Now to get y by itself, I have to divide by 8 on both sides. And now I'm going to reverse it. I'm going to start with my y. So y is by itself now. And that is equal to, and I can also make it a little bit more nicer and split it up, 9 over 8. Okay, so now my slope-intercept form tells me that the number in front of the x is my slope. So m equals 1/8 right here. And then my y-intercept would be a point. So I know my y-intercept always has the x value 0, and then my y value would be the b. So that is the very last number, -9 over 8. I found my slope and my y-intercept, and I am done. Again, make sure on your test you are required to type in these answers. Leave it as fractions if it's not stated to convert it into a decimal, and do not convert it into a mixed number. Leave it as an improper fraction. Read the instructions carefully. You don't want to lose a point even though that you knew the correct answer. Okay, somebody texted us. Let's review. Okay, somebody got lost. If you can state real quick where you got lost, then we can pick up and try to get you back on track. I will have Johnny communicate with you. So anyway, we are going to switch now because we always do that, and it's not so difficult, and you guys get somebody else's voice to hear rather than mine for 20 questions. Okay, we are going to switch real quick.
Thank you, Deanna. This is Johnny. Let's see here. Okay. So I guess we'll move on And then, let's see.
After you subtract 9 from both sides.
Okay.
Oh, she probably got lost when I switched equations.
Okay. So to try to clarify how we finished number 5, remember when she subtracted 9 from both sides, then she wanted to isolate y. So let's see, at this point here, she basically had 1 over 8x minus 9 over 8 equals y. But then to make it look just like slope-intercept form, we just flip the equation around. So we just picked it up and flipped it over. So the y now that was on the right, we moved it to the left here, and then the 1/8 x minus 9 over 8 that was on the left, it's now on the right. It's basically saying, if A equals B, then that means we can say that B equals A. So that's basically what we did so that we can make our equation look just like slope-intercept form. And so we can identify what the M, which is the slope, and what the B, which is the y-intercept. And we have the y-intercept as an ordered pair. So hopefully that helped clear up some things. Okay. All right, so let's look at number 6. So write the equation of a line through the given points in slope-intercept form. So remember that, just a reminder, y equals mx plus b. That's slope-intercept form. So if we're going to write an equation in slope-intercept form, we need the slope, and then we'll need the y-intercept. Quick question, do we want to use point slope? Gotcha. All right, so first let's start by getting the slope. So let's label our 2 points. So we'll call this first point x1, comma, y1, and the second point x2 and y2. So the slope formula is y2 minus y1 over x2 minus x1. That's how we can get the slope of a line given 2 points on the line. So now that I've labeled my points, let me just plug in those values here. So we've got 6 minus negative 7 over 2 minus negative 5. So 6 minus negative 7 is positive 13 over 2 minus negative 5 is positive 7. So the slope of our equation is 13 over 7. Now we want to work on getting the equation. So let's use point slope formula, and then we'll rewrite our equation into slope-intercept form. So that's y minus y1 equals m times x minus x1. So basically the x1 and the y1 we're getting from one of our points that were given to us. We could use either point. We could use negative 5, negative 7, or we could use 2, 6. It doesn't really matter. Just since I already labeled my points, I'll go ahead and use the first one just to be consistent. So remember, m is your slope. So I'm going to plug in my x1, y1, and m. So y minus negative 7 equals 13 over 7 times x minus negative 5. So minus a negative becomes y plus 7 equals 13 over 7 times x plus 5. And now I need to distribute the 13 over 7. So that's going to be 13 over 7x plus 13 times 5 over 7. All right. So that's going to give us, and on the left we still have y plus 7. So that's basically going to be y plus 7 equals 13 over 7x plus 65 over 7. Now I need to subtract 7 because I want to isolate my y so it can be in slope-intercept form. So I'm going to move up here. So that's going to be y equals 13 over 7x plus 65 over 7 minus 7. So Deanna showed you how to get common denominators to add or subtract fractions. I'll show that as well just in case. So let's see. 65 over 7 minus 7. So we need to get common denominators. We need a 7 denominator. The least common denominator will be 7. So if we multiply the top and bottom here by 7, that'll give us 65 over 7 minus 49 over 7. And so that's going to give us 16 over 7. Let me bring down the rest of my equation. Y equals 13 over 7x plus 16 over 7. So this is our final equation in slope-intercept form. So you can see here the slope was still at 13 over 7, and then the y-intercept, which is your b, is 16 over 7. Okay. Any questions about this problem? So I know we had a lot of algebra involved, so please feel free to ask. You're going to have to know these formulas like slope-intercept form, point-slope form, you will need to know for your test. The slope formula to find the slope using 2 points, you will need to know. You won't be given those formulas on the test. So you want to be sure and memorize those and know how to use them for your test this week. All right. Okay, so write the equation of the line. Write the equation in slope-intercept form. So the information that's given to us is that our equation needs to go through the point 7, negative 2, and it needs to be parallel to 8x plus 3y equals 38. So in order for us to use that information, we need to know first what is the slope of the given equation. And at this point, we don't know. The best way to figure out the slope would be to put it in slope-intercept form. So we want to get y by itself. So I'm going to start by subtracting 8x on both sides. So then I'll have 3y, make that 3 look a little better, equals negative 8x plus 38. And then to isolate y, I'm going to divide everything by 3. So that's going to be y equals negative 8 over 3 x plus 38 over 3. The reason why we did this is so that we can identify the slope of this given equation. So the slope of this equation is negative 8 over 3. So if we want our line to be parallel to this equation, we need to use the same slopes because parallel lines have equal slopes. They're the same. All right. Equal slopes. So just to make sure we're clear on parallel and then of course perpendicular, you guys type in what would be the slope of the perpendicular line. We're going to use the parallel we're going to find the parallel line. But if we were trying to find a perpendicular line, what would be the slope of that perpendicular line? Because on the test, you will have both questions. Either, both, but you need to know both of those vital pieces of information. So just because this particular question says parallel, you do need to know about perpendicular lines as well. All right, so while we wait for that, we'll go ahead and continue with this problem. So we have the slope that we're going to use, which is -8/3. So we'll say that m is -8/3. And then we have a point that we can use that's given to us, 7, -2. So remember point slope formula, y minus y1 equals m times x minus x1. So that x1 and y1 comes from the point given to us. So we have y minus -2 equals -8/3 times x minus 7. Y minus -2 is y plus 2. And then we're going to distribute that -8/3, -8/3x plus -8/3 times -7 is positive 56/3. And then finally, we're trying to get this in slope-intercept form, so let's subtract 2 on both sides. So we have y equals -8/3x plus 56/3 minus 2. So let's get a common denominator. The least common denominator will be 3. So if we multiply the top and bottom by 3, that'll give us 56/3 minus 6/3, which we know is 50/3. So our final equation would be y equals -8/3x plus 50/3. This is our equation in slope-intercept form. Notice that our slope here is that same -8/3 as the slope of the equation that was given to us. And yeah. All right. Good. So we've got some answers for our question about what would be the perpendicular slope. And yes, it would be the negative reciprocal of this given slope. So the negative reciprocal of -8/3 is positive 3/8. That would be our perpendicular slope. Very good. Great job. All right. And with that in mind, let's look at number 8. So determine whether the given lines are parallel, perpendicular, or neither. So we have two equations, and we need for them to get in slope-intercept form so we can identify the slope. Let's start with the first one. 3x minus 8y equals 11. So let's subtract 3x on both sides. So we have -8y equals -3x plus 11. And then we want to isolate y, get y by itself. So we'll divide everything by -8. So y equals negative divided by negative is a positive 3/8x. And then a positive divided by a negative would be -11/8. So the information that we need is the slope, which in this case would be m. Because remember, slope-intercept form, y equals mx plus b. We want to look at this coefficient of the x. So the slope for our first equation is 3/8. So let's just hold on to that information and look at the second equation. 32x plus 12y equals 11. And again, we want to get y by itself. So we'll subtract 32x from both sides. So 12y equals negative 32x plus 11. We'll divide everything by 12. So we have y equals negative 32 divided by 12x plus 11 over 12. Okay, so right here we see our slope right now is negative 32 over 12, but this can be reduced. So let's see, here we've got negative 32 over 12, but it can be reduced by a common factor of 4. So if we divide the top and bottom by 4, that will give us negative 8 over 3. So the slope of the second equation is negative 8 over 3. So if we compare the first and second slopes, they definitely are not equal. So that would rule out parallel. And perpendicular lines have negative reciprocal slopes. You flip and change the sign. So 3 over 8 and negative 8 over 3 are negative reciprocals. So our two equations are perpendicular. Okay? And of course it's not neither because it's perpendicular. Any questions about number 8? So just so we can understand what would it be if it was neither, so give us an example of when you would have two equations or two slopes that are neither parallel or perpendicular. What could be those two slopes? You can get really creative here. All right, let's look at the next one while we're thinking about that. Determine whether the relation is a function. So we've got a set of points here. Let's list them here. So our x values are negative 8, negative 5, negative 2, and 3. And our y values are negative 5, 8, 7, and negative 2. So let's look at how they connect. So negative 8 goes to negative 5. Negative 5's y is 8. Negative 2's y is 7. And 3's y is negative 2. So in this case, every x value only has one y value. So this would be a function. Yes, that would be a function. If one of our x values went to two different y values, that would not be a function. But this relation is a function. All right. All right, so we got a great response for our example of slopes that would be neither perpendicular or parallel. So someone said 1/2 and 7. Exactly right. Those would be an example of the two equations being neither parallel or perpendicular. Very good. Great job. Okay, number 10, determine whether the graph is the graph of a function. So when you're given the graph of a function, or you're given a graph, to see if it's a function, you want to use the vertical line test. So basically, you want to see if no matter where you were to draw a vertical line, you would only cross the graph one time. If there's anywhere on the graph and you draw a vertical line, okay, that's supposed to be a straight vertical line, and if you ever cross the graph more than once on that vertical line, it does not pass the vertical line test and it is not a function. So as you can see here, this is my pretend vertical line. It's very straight, of course. And as you can see clearly, it's crossing this graph two places simultaneously. So when I draw a straight vertical line up and down, it's crossing the graph twice. So it fails. So this would not be a function. And for this particular graph, there's so many places it fails. Anywhere you draw a vertical line that crosses this graph, it will cross the graph more than once. So it fails the vertical line test, so it is not a function. Alright, so we're going to make the switch again. Here's Deanna. We'll see you in a few.
Okay, let's move on to the next question. Question 11. So find the function value, and you have a function, so let f of x equal x squared minus 4x plus 2, and we are asked to find f of 1. As you notice, usually it says f of x, so this means whatever is in here, so in this case 1, has to be replaced for every x in the function. So let's plug in a 1 for every x we see. So 1 squared minus 4 times 1 plus 2, and then let's solve the right side of this function. So 1 times 1 is just 1, negative 4 times 1 is negative 4, and then plus 2. Let's continue down. So 1 minus 4 is negative 3 plus 2. And last step, negative 3 plus 2 equals 1. So this means if I evaluate f of 1, I would get 1. Let me know if you guys have questions. Okay. Question number 12. Find the domain of the function. Write the answer in set builder notation if applicable. Alright, so actually 12 and 13 kind of go on together because they have the same instructions. They're just two different types of function. Let's start with number 12. I know for you guys it's hard to visualize these type of functions, but in your book, I believe this is on page 56 and 57. There are all different types of functions that we are dealing with in this course, and you can kind of visualize there how they look like, and also it's a summary of what their domain and range would be. But whenever you have an x squared term, and that is your highest degree, the squared, then we are talking about parabolas. Parabolas look something like that. They could go opening up or opening down. And if you notice, the domain means are all the x values. So if this was the x-axis, so the arrows are indicating that this parabola continues to open up in either direction, which means the values, the x values of the domain also would increase in either direction, into the negative infinity and also into the positive infinity. So writing this in set builder notation for this particular one would be the solution all real numbers, because every single x value is a solution to this function. So you would have to write all real numbers for this one. And And let me see real quick. Okay, so when you are taking the test, if you have this version of the problem, because remember the page that I just told you, there are multiple different types of functions, so you can get either one of them and you are asked for their domain. If you happen to get this version, read the instructions, because it asks you to put A or N for all real numbers, okay? All right, now let's move on to number 13, which is a different type of function. So kind of visualizing this function on a graph, that function, the original function, would look something like that. Starting at 0 and then opening to the right direction. But there we have another value here, so it might gonna look a little bit different, but it basically has the same type of behavior. So again, when we're talking about the domain, we're talking about all the x values, so we know it starts somewhere here and then it goes in a certain direction. To find this, whenever you have a square root function, this is what this is called, you have actually a tool to solve this. You take the part under the square root, which is 20 minus x, and you set it equal to or greater than or equal to 0. Because remember, I said originally it starts at the 0 point, but if you have something else there, it might be shifted to the right or the left. And to find out, you use to write this with a greater than or equal to 0. Now you're solving for x, so subtract 20 from both sides. Negative x is greater than or equal to negative 20, and then divide by a negative 1. Remember what happens if you're dividing by a negative number, the sign flips and it's equal to positive 20. Okay, so writing this in set builder notation, x such that x is less than or equal to 20. Okay, so different functions, different type of ways to find their domain. Kind of get familiar with all different types of functions and how to find the domain. But here are two of them. Okay, so I had a little hint, and I have to apologize. I'm like really tired because I was like looking at your attendance post last night to find out at which campus you guys want to take the test. I didn't realize that I might should have put the due date a little bit earlier rather than letting you guys submit all the way to 11:59 in nighttime, because that hardly gave me any time to submit your test referrals for the testing center. But I'm all done now, so I guess I made a little mistake. And thanks God you guys are awake. So write here question 11. When I said -3 plus 2 is 1, that's absolutely incorrect. And the correct answer should be -1. So I'm sorry for that, but I'm glad that you guys are actually functioning and paying attention to what we're doing here. Thank you to the student that noticed. Okay, so now let's move on to 14, which asks us to find the slope of the line if it exists. So we are given a graph, and here is our line, and we are asked to find the slope. Well, for linear equations, there are basically two different special cases. It would be the vertical line, which is this, and then you also could have the case of a horizontal line. So either one of them is 0 and the other one is undefined. do you guys know which one is this line? I'm going to give you guys a second to type in if this one is the version where it's undefined or 0. So we are looking for the slope. We're using M for slope. And we have an answer. Very nice. But I want to see if other people get the same answer. Okay. So this is correct. The answer is undefined. Undefined. And then for the horizontal line, the slope would be 0. And to know why this is undefined, remember that the slope formula is y2 minus y1 over x2 minus x1. So you can randomly pick 2 points on that line, for example, this point and let's say this point, and this one here would be 8, 0, and this one on top here would be 8 and then 1, 2, 3, 4, so 8, 4. And now if you would use these 2 points, and it doesn't matter which one you call point 1 and which one point 2, only once you label them, keep the labeling. And if you plug this into the formula, so y2 in this case is 0 minus y1, which is 4, and then x2 in our case is 8 minus 8. So on top we get a negative 4, and in the bottom now this would be 0. And in math, when you are dividing by a 0, this is undefined, because there is no way that you could do the reverse and whatever number you're saying it would be, for example 0, there's no way you would multiply these numbers together and then get back a negative 4. So it's undefined. Vertical lines are undefined and horizontal lines are 0. Question 15. I know not a lot of people like word problems, but let's attempt this one anyway. So solve the problem. The average tuition at a public four-year college was $3,032 in 1997 and $3,218 in 1999. Find and interpret the slope of the line representing the change in tuition to the nearest dollar per year. So I got 2 values here. I got the amount of tuition and the year, and I got another value, the amount of tuition at a different year. Basically, I have 2 different values at 2 different times, so I can use these as points. So 3,032, 1997 could be one of my points, and then the other one is 3,218 with 1999. So I have 2 points and they want me to interpret the slope. The slope is also the rate of change. And in the previous problem, I just wrote down the slope formula, which hopefully by now you guys already know. So y2 minus y1 over x2 minus x1. And I can label my 2 points. So let me call this one x1 and y1, and this one x2 and y2. And now I'm plugging this into my slope formula. So y2 is 1,999 minus y1, which is 1,997, all that over 3,218 minus 3,032. So solving these two parts separately, I get 2, and this one, maybe you guys want to help me out real quick, because I know some of you probably already working ahead and are faster than me talking. So what do we get? 186. Okay, because we have a fraction, we might want to check if we can reduce it, and because both of these numbers are even, I'm pretty sure that I can simplify by 2. So when I divide both by 2, I get 1 on top, and 186 divided by 2 is 93. Okay, so now they want me to interpret this slope based on this problem talking about tuition. Because I have a positive slope, that means increased. Increased is positive and decreased would mean negative. So I'm going to have this sentence here, like you will have on your test, and just type the word that you think it would be. So a positive slope, it should be increasing. Increased. Make sure you spell it the right way. And then by how much did it increase per year? Okay, because the top part basically gave me the year, right? And it's 1 year, so per year. And the bottom number is the dollar amount, so it increased by $93 per year. Okay. I'm going to wait a second to see if somebody has a question before I moved on. So the hardest part is to interpreting whatever answer you get into a word problem. Originally, you could have switched these two numbers too, putting the y value instead of the x value. But as long as you know when you're getting an answer what that means, you are fine. Okay, so no questions. We are fine with word problems. I'm going to switch with Johnny now again, and I'm pretty sure there's going to be more of these.
Alrighty. Okay, so let's have some more fun with these. Word problem, solve the problem. Using a phone card to make a long distance call costs a flat fee of 12 cents plus 24 cents per minute starting with the first minute. Find the total cost of a phone call which lasts 21 minutes. Round your answer to the nearest cent. So we need to write an equation that models the situation. And when you have cost, cost is typically the dependent variable because it depends on the other variable. So basically, the number of minutes, the cost depends on the number of minutes. So it's kind of like, so if we think of it as like C of X. So, and we'll let X represent the number of minutes. Alright, so So we need to, and C represents the cost in dollars. All right, so your cost is a flat fee of 12 cents plus 24 cents per minute. So every minute you add an additional 24 cents. So I'm going to say the cost of 12 cents plus the cost per minute of 24 cents. So we're going to multiply 24 cents times X and then add that to 12 cents. So basically, if it was 1 minute, it would be 12 cents plus 24 cents times 1. If it were 2 minutes, it would be 12 cents plus 24 cents times 2. So this is my equation modeling the situation, and it says to find the total cost of a phone call which lasts 21 minutes. So we want to find our cost when X is 21. So I'm going to plug in 21 in for X. So 0.12 plus 0.24 times 21. All right. And now we've got 0.12 plus 5.04. That's going to give us $5.16. And it says to round your answer to the nearest cent. And so that is basically the same as rounding to the nearest hundredth or 2 decimal places. So this would be our final answer here. So that would be $5.16. All right. Okay, so thinking about some possible answers that could be on your test. Let's say, for example, the answer is $5.50, and it says to round to the nearest cent. When you put your answer when you type your answer on the computer to give your correct answer, make sure you include that 0 in the 50 cents, because when it says to the nearest cent, they want you to write your 2 decimal places. They want you to show that hundredth place. They want you to show that second decimal place. So make sure and write both decimal values on your test. All right, let's move on to number 17. More fun. So the cost of having a car towed is given by the linear function c of x equals 2x plus 50, where c of x is in dollars and x is the number of miles the car is towed. Find the cost of having a car towed 15 miles and round your answer to the nearest dollar. So this one's nice because it gives us the formula, not the formula, I'm sorry, the equation that models the situation. So it's c of x equals 2x plus 50. And they tell us that x is the number of miles and c is the amount in dollars. And so they want us to find C when X is 15. So we want to find C of 15. So we're going to plug in 15 in for X. So we have 2 times 15 is 30 plus 50 equals 80. And they want us to round your answer to the nearest dollar, and it's just $80. There's no cents here. So our final answer would be $80. Okay? So sometimes you'll be given the equation that models a situation, and sometimes you'll need to come up with that equation modeling the situation. But it's helpful to remember which variable is independent and which one depends on the other information, and that can help you determine which is your x, which would be your independent one, and which is your y, or whatever variable you want to use. Okay, number 18. Use the graph of the function to answer the following questions. Find f of 0, and then find x when f of x is -3. So remember that f of x is the same thing as y when we're thinking about the x and y coordinate plane. So f of x is just called function notation. But basically, so let's look at the first one, f of 0. So basically, when x equals 0, what is my y? So if we look at our x-axis here, let's go to where x is 0. That's here. So where is my function? The y value is at -8. So when f of 0, when x is 0, my y is 8. -8, sorry. -8. Alright? So now it's asking for the x value when y is -3. Because remember, f of x is the same thing as y. So when y, or f of x, is -3, what is, or what are, my x values? So here is -3 on the y-axis. Let's just draw a dotted line to help us see what's happening on our graph. Okay, so as you can see, when y, or f of x, is -3, your x value, there's actually two x values. So here and here. So this actually gives you two different x values. So when f of x is -3, x is -5, and x is +5. So we can see that here and here, because that's where our y values cross the graph. Alright, so on your tests this week, when you put your answer into the computer, you want to write it as -5, 5. Make sure you write the smallest answer first. Okay? Write the smallest value first. And these little tidbits and hints that we're telling you, they are on the test, very detailed and explicitly explained, but we want to make sure you're aware that these are things that we will be looking for so that we can accurately grade your tests. All right? Any questions about number 18? Okay. Let's look at 19. Match the graph to the function listed whose graph most resembles the one given. So it's going to be really helpful for you to have an idea of what these parent functions look like. So this particular graph here actually models the square root function. That's answer choice C. Okay? But just so you're clear on what these look like, let's draw sketches. So just as long as you know like a general look for these, this will help you for several questions that deal with different types of functions. So linear function is basically a straight line. It can be positive, slope, negative, vertical, horizontal, it doesn't matter. Basically, it's a straight line. A square or quadratic function is a parabola or a U. And the U can be facing up, it can be facing down, but it's a U shape, parabola shape. we'll talk more about those later. Square root function looks like the one that we have here. The cube root looks like sort of like the square root, but it has this part and it also has that part. The cube function looks similar, very similar, but it's kind of translated or moved the other way. It looks like this. These are just rough sketches of the parent functions. The reciprocal function looks like that, roughly. And then the absolute value function is a V. And it can be going up or down, left or right, but this is just like a basic sketch. So it'll be helpful for you to memorize these very basic sketches of these different types of functions. Okay? And you can even create examples of these in your graphing calculator if you were to, type in a linear function or type in a square root function. You should see something very similar to these. It may be translated, it may be shifted up or down, left or right, but they will look very similar. All right? Okay, then number 20. So, graph the function. So, let's practice using the graphing calculator. Let's see. And then I'll show you how you could sketch it without the graphing calculator. Alright, so if you want to put this in the graphing calculator, to graph a function, we're going to go to y equals. And then it may help you to, well, first of all, make sure that your y equals screen is cleared. You want to maybe set your window to, this is like the more standard window. Your x minimum is -10, the x maximum is 10, x and y scale is 1, and then the y minimum is -10, the y maximum is 10. Or you could do like a shortcut, and when you graph it using y equals, well, I'll show you another shortcut to make sure your window fits. There's a lot of ways actually you can do the same thing with the graphing calculator. But anyway, so if we go to y equals, and we want to graph the cube root of x, then we're going to see the cubed root. So you want to press math, and then we want to select the cubed root, which is option 4. You can either press the number 4, or you can scroll down to it, press enter, and then we're going to type x. And then to graph it, we'll press graph, and that gives us a sketch. Now let's say your window was looking different and you couldn't see what you felt like you wanted to see. If you press zoom, standard, that's a good one to choose because it gives you that standard window I just showed you. So you could, type 6, or you could scroll down to number 6. But here's the graph of the cube root of x. So you can take this and compare it with the ones in the question, and you can choose the appropriate graph. So if we look, are there any questions on using the graphing calculator to graph a function? And this will be very helpful for you in many ways when you take this test. Remember, you can use a graphing calculator on your tests. So if we go back to the function, so that would be option D. So, and then just to kind of show you how to do it by hand, you can make a little quick table. So let's think of some x values that I could plug into my function. That would be easy to solve. So 1 would be a good one. So when x is 1, y or f of x will be the cube root of 1, which is 1. So basically 1 comma 1 is a point on this function. So if you look, 1 is not a point on this function. That doesn't work. B, okay, 1, 1, that's not a point on this function. That doesn't work. 1, 1, that's not on C. So that automatically tells us as well that D has to be the function. And if you don't believe it, you can do another x value. Let's use 8, since 8 is a perfect cube. So the cube root of 8 is 2. So 8, 2 is a point on the graph. And if you look here, we can't see 8, so this is 6, 7, 8, but that would probably be on the graph. So this is the way you could do it without the calculator, but we want you to be, be familiar with using it. So let's go back and look at the graphing calculator. Let's practice graphing a few other parent functions. So remember, go to y equals, and then let's do a quadratic, which would be x squared. So we're going to choose x, and then there's actually a squared button, and then we say graph, and we can see our graph of a quadratic. Let's practice graphing a cube function, so that would be x cubed. So x, and then you can do a caret to the third power, or you could go to math. There's a cube function there. Graph. There you go. And then absolute value. So you would want to go to catalog. Let me double check. Nope, that's not it. Like I said, there's a lot of times multiple ways to get to something. So sometimes you can have a long way, but there's a shorter way to get to it. So in order for you to graph an absolute value function, so you want to go to the math option, and so you want to scroll to the right to number. So ABS, parentheses, is your absolute value function or input. So let's say I want to graph the absolute value of x plus 4. So x plus 4 is in the absolute value lines. So I would say x plus 4, for example, and close my parentheses. And so there it is there. I could even do just the basic parent absolute value function. So math, scroll to the right, number, and I want the first option. And then this is just the parent function, the absolute value of x. And then there it is. So being able to graph these functions on the graphing calculator is extremely helpful when you're answering these questions on your tests. Okay? Any questions on using the graphing calculator for this test? Everyone knows how to, like Deanna was asking about converting a fraction to a decimal to fraction, anything like that. All right, well, here's some test 1 information. So you have from now until February 1st, until 7 p.m. to take your first test in a testing center. So things that you'll have 2 hours to complete your test. Things you need would be a graphing calculator, TI 83 or 84, pencils. You need to have your VID with your photo ID in order for you to take a test in any Valencia testing center. Remember, the CRN for this course is 24944. The course, remember, is MAT1033C. And then when they ask you for the instructor, you can say instructional assistant Deanna Buddha or Professor Johnny Forsythe. Either one will get you the test. And then as far as Osceola Testing Center, the hours of operation are listed below: 8 a.m. to 9 p.m. Monday through Thursday, Friday 8 a.m. to 5 p.m., and Saturday 8 a.m. to 12 p.m. But remember, you want to give yourself enough time to take the test. So you need to get there 2 hours at the very least before they close. And they're not going to allow you to take the test if you don't have your 2 hours before they close. So if you show up on Thursday at 8:30 p.m., they're going to turn you around. So definitely think ahead and plan so you can get your adequate time. So anyone who didn't submit on their attendance post last week where they would like to take their tests, you will have to take it at the Osceola Testing Center. It has already been submitted. It's waiting for you this week. So if you did not submit your attendance post, then you are defaulted into taking the tests in the Osceola Testing Center. So remember, continue to monitor Blackboard daily. Check your emails. A lot of you are doing a nice job with communicating with us about any questions or possible issues or concerns with your homework and assignments. Communication is key. We are here for you. And are there any other final questions before we close out for the day? You guys have been great. So we will post this review session on Blackboard shortly so that you can review this as many times as you need to. And if there are no questions, we hope you all have a wonderful week. Have a great rest of the day. And best of luck on your test this week and any other assignments or assessments you may have. If you have any questions, you can stay online, but we're going to go ahead and end this study session. Have a great day.